January 2001. As India woke to its 52nd Republic Day, the sleeping earth arose to sudden chaos. Shrugging a massive shoulder,
we are waiting for the guest speaker to arrive in the meeting. Because of some problem, he was get disconnected again. So as soon as he entered, we will start the session.
Hello. Am I audible, sir?
Now today again we will be with us Dr. Nitin Kadaria sir, and again one for new interesting topic for this dampers or base isolators. Now he will be again presenting the new information with us. Sir, you can share your presentation now.
निकू सर, थोड़ा सा मेरा भी सामने की कॉलेज में ही चालू है, प्रेजेंटेशन चालू है। हाँ STP में, हाँ STP में। ठीक। Am I audible, sir?
Yes, sir. Yes, sir. Now presentation is now started.
Good afternoon, everyone. In the previous lecture, we have gone through with some basic base isolation techniques, which include the elastomeric rubber bearing, lead rubber bearing, and friction pendulum system. We have shown the different modeling, how to model that one for the analysis purpose. Okay, so today for today's lecture, I have considered two different things. First one, these are the smart materials, smart dampers are there. Okay, so like this is the first one, the systemic control of that curve, which by
Your screen has been not shared.
Sir, I already shared, sir.
No, but it is not appearing on our screen.
Okay, I am again.
Please stop and again share it.
Okay. Stop. Now it is visible, sir?
No, yes, it did not yet appear.
I will close my video and again I will just stop share and screen share. Base isolation techniques. Yeah, so it is giving the message UST screen sharing paused.
You just stop that. I will share my screen first. I will stop it and again then you can try.
Okay, I will stop it. Okay.
Let me share one simple screen.
Okay,
now you try to share again.
It is saying the paused actually. Your screen sharing is paused.
Let me check. No, it is actually I will stop it again. Once again, I will stop you. And now you again try. Yes, now it is visible.
Okay, sir. So good afternoon, everyone. Once again, we are moving. Today, we are watching one another topic, which is related to the vibration control of structure. In the previous one, we have gone through the some isolation techniques like lead rubber bearing, friction pendulum system, and elastomeric rubber bearing. Now, this topic is with some related with the smart material, use of smart material for in the instrumentation, so that we can control the structure, vibration of the structure. So in which the first one is the seismic control of curved bridge. This is my topic, using the MR damper. MR means the magnetological damper. What actually did it happen in the MR damper? We know the damper are used to control the vibration of the structure. Viscous fluid damper is the damper. Only changes that it is filled with the MR. What is MR fluid? Is a fluid which uh, uh,
Your voice is breaking.
uh, said that if there are
So there was connectivity issue with the internet. Kataria sir, please share your presentation. Yes, it is visible now. Yes, please unmute yourself. Kataria sir, please unmute yourself. Kataria sir, please unmute yourself.
hello. Can
Yes,
you hear
yes.
me?
Now I can hear you.
Okay, okay.
Now you can start again.
Okay. This MR damper, it is just similar to that of viscous fluid damper. Only change is that the whatever the fluid which is inside, that is the MR fluid. That is the fluid which contain the magnetically polarized particle, which is very fine microns in nature. When we apply magnetic field around the particle, what not the it changes the viscosity of the fluid as per the our requirement, and we will get the force two nodes. The force deformation behavior in case of this MR damper is just like a oval shape in nature. Okay, this is shown here, force versus displacement one. When there will be some excitation due to the earthquake, what happened due to this earthquake? There may be the velocity different is there. There's maybe displacement display is there between these two nodes. Okay, so whatever that velocity between this node and this node that have been calculated, and according to that the internal force we have to create, so that that force is calculated by using this model which is given by the Wayne in 2002. And this is it is depend on the n number of parameters. This modified Bock-Wayne model is utilized for the generation of the force. This is the force generation is given by this F is equal to C1 into Y dot into K1 into XD minus X0. Where is the XD is the displacement, X0 is the initial position, C1 is the coefficient of the velocity component, means coefficient of damping, Y dot is the velocity, and this Z dot and Z are calculated. The various parameters for the this magnetological MR damper is given by the this lot company itself for the 1-ton capacity damper. Okay, so if we apply this one, and we can calculate the value of the force damper, and the these parameters we are it is depend on are the this if we input maximum voltage, means what is the voltage provide 0 volt to 10 volt, we can vary the voltage so that the performance of the damper can change as per the requirement. Okay, so as it is a semi-active damper. Semi-active dampers means that it will operate on the battery power. As we observe that the voltage required is very less, 2 volt, 4 volt, 6 volt, 8 volt, whatever the voltage at that time that we can utilize, and according to that one we can generate the force in that damper, and we can save the structure. These are the formula which we have to calculate, and this is the formula for the calculation of voltage which is acting on the structure. So this is the volt formula is there in order to calculate the voltage that is in the structure. For the current stage, the optimum value for this damper is varying from structure to structure. So whenever we are applying in any structure, we have to firstly optimize, design it, what should be the voltage we can put so that it gives the optimum result. So for our case, I have chosen the same the curved bridge that we have done in the previous one, and we have varied the value of the voltage. So that low voltage will be efficient to reduce the maximum base shear, as well as to calculate the less amount of the shear force on the structure. If you observe, I have told you earlier that when we are using isolator, we are able to reduce the base shear in large up to 97%. Whereas when we are do the combination of this MR damper along with the elastomeric rubber bearing, here I did the combination with the along with the elastomeric rubber bearing. So it was observed that use of MR damper will reduces the response, means what it do, it reduces the shear force, but it will not reduce up to that extent when we are only using the elastomeric rubber bearing. But it also reduces the displacement. It do the displacement control of the bridge also. Okay, so here is the MR plus ARB are there. Then I also did the study for MR plus lead rubber bearing, and then MR plus the friction pendulum system. For all the cases, it was observed value of voltage when it is low, it will give the best result. This is the numerical study of MR plus passive isolation system, which give the time variation versus base shear for the Kobe earthquake as well as for the earthquake in chord, radial, and normal, all three direction. It is observed that when we are using only isolator, there is higher reduction in the base shear. But when we are using isolator along with the damper, it will provide the good result. Not only to control the base shear, base movement, but also to control the deck displacement too. So this is the force deformation and behavior actual for the different earthquake of the MR damper, which I have applied at the between the deck and the pier cap. Okay, so this is the force deformation behavior if you observe the for viscous fluid damper VFD, if it will be just simple like this. Okay, but as soon we are using MR damper, here the area under the curve is higher, means the amount of energy deposited is large as compared to the viscous fluid damper. So it is very useful, and nowadays in the various countries it is also used to control the structure. When we are unable to apply the voltage at that time, it will act as a passive damper, simple passive viscous damper. Okay, because the viscosity of the fluid is not changing. Here in this case, as soon as we applied the current voltage, what happened, the viscosity of the fluid changes, the thickness of the fluid changes, and then due to that one, the force in the two nodes of the damper will be varying from time to time as per the requirement in the structure. So these are the again the results, and we can so conclude from this study that the based on the investigation, the significant that response can be reduced by using the hybrid combination. And another one is the just some modification in the viscous damper. We can make another damper. This is the semi-active variable stiffness damper. Semi-active variable stiffness damper. What happened if we observe the viscous damper is nothing, it is made up of one cylinder in which one piston is there, which has the n number of orifices are there, and then it contained with a fluid. That fluid viscosity, according to that fluid viscosity, the at the different node we have the value of the forces we can calculate according to that one. But this is the semi-active variable stiffness damper. It is what it has the chamber which is made up of piston and which is pack in nature in generally. Okay, so it has not any orifice. Apart from this, there is a external wall is there, which is control wall is there. That control wall controls the fluid flow from one chamber to another chamber. So what happens if we close this wall? Okay, it will produce very high stiffness. Whereas if we open this control wall, this piston move easily. This very less stiffness can be occur. Okay, so these two situation can be occur for producing the damping force. So this is another type of semi-active damper, which is semi-active variable stiffness damper. Having name itself suggests it is the variable stiffness damper. The post deformation behavior for this damper is like this. Just when it is on off type, means when control is on, the damping force will be this one. When control is off, it becomes the zero damping force. Okay, so the simple the force generated along the two nodes is given Fi is equal to Ki Hi Vi into Ui. Okay, so this depend on the Kf into Kc upon Fc. This is the whatever the frame stiffness is there, that frame stiffness we have to also consider for calculating the total force structure. Then stiffness ratio is the ratio of that frame stiffness divided by the K isolated stiffness. Okay, and this device will be work. Hello. Yes, this device is also work actively as well as semi-actively. Means passively, actively as well as the passively. When the VSI means that is equal to 1 or 0, this is the control force. Means when we are taking it is 1 or 0, it will show that wall is open or wall is closed. Okay, so when we can say that will be equal to 1, it will act as a only always passive in the nature. If they are supposed to be at the time of earthquake, is due to some power failure, etc., we are not by using algorithm, we are not able to control the opening of the this wall. Okay, so if wall opening is not controlled, it automatically either it may be closed or either it may be open. Okay, when at that time VSI will be 1 and it will be act as a passive system. Whereas otherwise, if you use the switching control laws or modified switching control are there, that velocity difference in an adjacent node is equal to greater than 1 or less than 1. U into U, that will give the value of VSI force. Yes, according to that, the forces are generated in the this two node, first node, and with respect to that one, and we can say that the forces are actively in structure, and they going to dissipate the whatever the energy this is the very simple one in which it is mainly depend on the stiffness ratio. Means whatever the stiffness we are going to provide here, as per the fluid viscosity, that we have to consider only for the analysis for optimization purpose. Okay, so this is I had did for my bridge structure. It was observed that lower value of the stiffness ratio is beneficial in case of all LRB and APS. And then one can utilize this device for reduction in the base shear, base movement, as well as the to control the deck displacement of the bridge also, as well as this can be utilized for the controlling vibration control of the various structure. This is the post deformation behavior which for the different earthquake, which for one of device which I applied in between the deck and the pier cap. Okay, so this in our same result, I can say lower value of the KR will be the better for reducing the base shear and the overturning movement, whereas the higher value of pump for the lesser mid-span displacement of the bridges. Okay, so this is the another semi-active device, and another one is the piezoelectric friction damper. It is a very interesting one. It is just invented in around 2000, and very few researchers had did work on that piezoelectric friction damper. Nowadays we are know that what is firstly friction damper. I think so in the previous lectures I told you that friction damper just we can utilize the by using the coefficient friction by applying the normal force on the structure. We are using the friction damper for dissipating the energy which is introduced in a structure. In piezoelectric friction damper, a new material which is known as the also known as the smart damper. It is one material that is known as the piezoelectric stack. It is utilized. Piezoelectric stack, it is a piezoelectric material, has a unique property. When we apply force on a piezoelectric material, it will produce the electricity, and when we apply electricity on that one, it changes its shape and size, which it swell or it shrink, like this happening in this the piezoelectric material. Okay, so what we have utilized this one when we are we are placing the piezoelectric stack like as shown in the figure in the friction damper. In between that one, we are applying the electric force electricity current in this damper, and due to that electricity, it changes its size. It will swell or it will shrink, and automatically the normal force between these two surfaces, it is changing. As normal force is increasing, the friction force is also increasing, and that will give the whatever the required force at the to damp the forces which is acting to in between the two story. Okay, so the piezoelectric material are very important. If you observe, some n number of videos are available on YouTube also. Piezoelectric material, if we convert in any shape and size, and if we supposed to it is temperature it's increase, it will or decrease, automatically it will come to its original shape and size. Same thing is happening here also. The we know the this frictional force F is equal to mu into n. Mu is the coefficient of friction. F is equal to mu into n is in general form which are using we are engineering. Same thing is there. This normal force we are actually managing by using the piezoelectric stack. We are providing some current voltage difference in the piezoelectric stack, so that it will swell or it will shrink. Automatically this normal force varying, and according to that normal force the friction force is also varying, and then we will get the forces. We can apply the forces equal in opposite direction at the in between two, and we can reduce the whatever the damping coming in the structure. We can apply the damping, and we can reduce the response of the structure. The basic formula force acting on structure is the F is equal to 2 into mu into n, and I into signum function of velocity. This is signum function of velocity is nothing but the +1 or -1 in which direction we have to apply the force. That is the 2 into mu into n is the simple. At two places we are conducting, so the 2 mu d is the coefficient of friction, n is the normal force which we are generating. Normal force we can generating is the n pre plus 4 times this formula. For that piezoelectric material is the standard formula is there. N pre is the whatever the initial n pre is there, means supposed to be if there is no voltage we are applying, not anything applying, so this term will become 0. This term will become 0. There will be n pre. N pre means initial some normal reaction is there, and automatically due to that normal reaction this friction force is also coming on the structure. Okay, so automatically it will act as a passive device also. It will act as a passive device also. So this is actually depend on the various parameter. First parameter we can here itself n pre, we can change the n pre less to maximum, means 100 kilonewton to 2000 kilonewton, whatever the as per our requirement. Then other parameters are the voltage input are also there. Then this n pre ni is calculated by using the voltage division at the different node, etc. Means it is totally depend on the 4 parameter: coefficient of production, n pre, voltage input, as well as g gain factor is also there, which will give you the optimistic value for your structure. Okay, so for the current one, current structure, what I did, firstly I choose some value as n pre is equal to 1000 kilonewton, and I three things I will take it constant, and then I will optimize first one, second one, third one, and then fourth one. And I'll also observe the result for the passive case, means when there is no force, only n pre is applicable and all other are parameters 0, what will be its effect. So it was observed that in generally first one, this is the variation of this effect of coefficient friction on the damper. It is just simple, means this coefficient of friction, it is increasing automatically, like is in a friction damper. We will have the less reduction in the force, as well as the there will be a maximum reduction in the deck displacement. Second one will be the this effect of gain factor G. The gain factor is varying from 200 to 2000 kilonewton second per meter. Okay, so that gain factor we have to study and we have to find out its optimum value. And then third one is the variation of the gain ratio, that is E by G. Okay, so that E by G also we have to study. And last one, the coefficient of n pre, that is normal reaction, which is initially whatever we may say, there is no effect of n pre at all, because as it is depend on the structure to structure how we can behave it. Okay, but it is the one of the optimum value for my structure. It has comes to be around 0.1 for the coefficient of friction, which is very useful to reduce the maximum response. Then gain factor is 0.1400 kilonewton per meter square. Gain ratio is equal to 5, and n pre is equal to 100 kilonewton. Means we can vary its value high, but when we are making its value high, it will producing higher frictional forces. Sometimes what happens that for the small earthquake, it will not come to the in the sleep mode. It will be only in the stick mode. So we have to keep the n pre value less as possible. Okay, so this is the one of the best new smart damper, piezoelectric friction damper, which is nowadays used by the various researcher for doing the research, as well as it is applied at the various locations. These are the some reduction observation that observed that around 82% reduction in the base shear in the chord direction, 93% in the radial direction, and for peer 1, peer 2, then using the ERB combination, LRB combination, and FPS combination. In all combination, it is observed that friction pendulum, this piezoelectric friction damper, along with the lead rubber bearing, is giving the better result, overall better result. Means what we can say that for base shear reduction, elastomic rubber bearing is very good. Higher damping rubber bearing we can utilize. But when we are using lead rubber bearing, it is also controlling somewhat displacement response of the deck also. Okay, so we have to think overall, not only for one parameter. So for overall parameter, this piezoelectric windshield damper along with the lead rubber wearing is giving the best result. So these are the some result. And if you observe, this is the tri-directional time history analysis was carried out. All three direction of earthquake has been utilized in chord direction, radial direction, as well as in the vertical direction. And it was observed that in case of radial direction, around 97% reduction of the base shear was observed as compared to uncontrolled response of the structure due to the utilization of this hybrid combination. And whereas in case of the chord direction, the maximum reduction was observed around 96 and 94%, and which is also very good. And it is also reducing the response of the structure. The post deformation behavior is just like a butterfly type. Okay, so automatically the if area of the post deformation loop is higher, automatically it will reduce the huge amount of damping. It will
Yes.
produce the huge damping. Okay, so friction damper is just a single right angle box is there, whereas it is like a butter shape lies there. So again we can have the conclusion, it is actually specifically for the curved bridges purpose. And in case of the structure also, you have to optimize this by using this different parameter. Okay, so these are the few new dampers which has utilized by the race researcher nowadays for doing the research. And the modeling point of view, if you I will say that you have to model this damper, magnetological damper or friction pendulum system, supposedly this piezoelectric friction damper. The, till date we can't do directly analysis in SAP, ETAP, SAP or StatPro. Okay,
Okay.
you have to do model it in case of MATLAB. You have to do modeling of your structure in the MATLAB. Then you can model this also damper as the we have the force of the damper. These are different different formulas are there. Using this formula we can model in your MATLAB. Okay, modeling is very easy for your multi-story building also, because people think that using the MATLAB is very difficult, but it is not so one. As here we are using our calculator, a plus b is equal to c,
Yes, sir.
or that one, like that only MATLAB is there. It is very easy actually. Okay, so even our building analysis and design is also very easy. If you have did the coursework of matrix method of structural analysis. Okay, so you have to only some assumption you have to make, like during if you have to do earthquake analysis, we can directly say that the our building will be in the shear mode, so 12 EI by L cube will be the whatever the moment which shear will be coming, that we have to consider only that mode. And according to that we can make a matrix of n multi-story building, supposed to be 12 by 12 story building is there, so we can convert into 12 by 12 matrix, and then mass matrix we can make. Then from mass matrix and from stiffness matrix we can calculate the damping matrix. Can assume that 5% of internal structural damping is there. For that one we can use the a0 into m plus a1 into k. Using that formula we can calculate the c matrix, simple is there. And by using first two mode of vibration we can put the value of a0 and a1 there, and we can calculate the value of the c matrix. Then after calculation of c matrix we can provide all the unknowns, like I will show you. Just I want to show the equation of motion of that particular any structure, so that it will be easy for you. Yes, in this case, we have calculated mass matrix first. We have calculated K matrix. From that K matrix, we have calculated the C matrix. Now, whatever that M into N into UG dot, UG is nothing but the time history you are. So from time history into mass, and N is the vector which is showing the 1010, means in which direction you have to apply the earthquake. That will provide the N matrix, and this also known. So and whereas U double dot and U dot and U is the displacement, velocity and acceleration, that we have to find out. This all these three things we can find out by using the numerical, if you are using time history analysis, simple is there. Numeric beta is best method in which linear acceleration or average acceleration one can use very easily. So we can apply the different how this is the B into app equation location we provide that damping force, and tau is nothing but the force due to damper isolator etc., which is a here. And then using time analysis using
Internet connection goes off at the Kataria sir end. He is restoring soon. So till then, participants can type their question, and then we will end today's meeting. So you can type your question in the chat box. Kataria sir. So you are host now. Your voice is not audible. No voice. You please make me host. I actually made you host.
okay. So hello now. Hello.
Yes,
Now
sir.
can
Please.
you hear me, sir?
Yes, sir. Yes, sir.
Okay. So okay, so this is the simple way by which one can do the time history analysis, and this V vector will give the position of vector, different location of that damper where we are providing by using 1010 like this, and the f of t is giving the value of that one forces generated across the damper. Okay, so if anybody have any question, please ask.
Yes, sir. Please type the question in the chat box, and then we will end this session. Kataria sir, by the time you please make me host.
Okay, okay, sir. So you are no host, sir.
Yes, sir. Now it is okay. So I think there are no more questions are there in the chat box. But this was a very interesting. All these three types what you explained, sir. That again we can utilize for some other different types. So you are using it for bridge analysis.
Yes.
So then it can be applied for other places, and that same analysis or research can be carried out for this combination of the different
damper along
Dampers.
the isolator.
Yes, sir. Yes, sir.
Yes, as well as one thing you should know that all isolator are only utilized up to some height of story, means up to 20 story max, 15 to 20 story building.
Yes, sir.
Then isolator will not useful for the building. At that
Yes.
time, for the vibration control, the only thing is that damper can be utilized
Yes.
for the vibration control.
Yes, sir.
And it is not necessary that that isolation system always can be placed at the ground level. It can be
Yes.
placed at the some other story level also.
Yes. Yes. Yes.
Okay, as per the requirement, as per the vibration control requirement of the structure.
Yeah.
If anybody have question, please ask. Something three people.
Yes, sir. So I think there are no questions in the chat box. Okay, sir. Thank you, Kataria, sir.
Thank you, sir.
A new interesting topic you have highlighted with this presentation. I also thanks to all the participants for the patience listening and be with this, us for this 4th day of STDP. So now here we will stop for the today's session, and the 5th session will be there. That link will be shared on the WhatsApp group so that you can watch that video for the 5th session of this today's STDP. And tomorrow again we will be having all the dynamic experts. So Dr. Putul Haldar will be there for our first two sessions. Now she will be again guiding you, on very interesting topic. And then there are hands-on also in the afternoon session. So tomorrow again we will meet at 9:30. So thank you, Ugle sir, and all other faculty members of Department of Civil Engineering, Professor Ramey, College of Engineering and Management, Badnera. And I also thanks to all the participants for being with us and making this success, STDP, great success. So thank you here from my side. Ashish Ugle sir,
Sir.
is there any announcement from your side?
Yes, sir.
Is there any announcement from your side?
No, sir. Nothing will be there.
Okay. So we will stop for the day. Thank you, Kataria sir, once again.
Thank you, sir.
Thank you, sir. Okay, so I will end the meeting in 5 minutes, and tomorrow we will meet at 9:30 AM again.
Okay.